Hello students, I am Dr. Krupa Rasane, Professor and Head ENC, Jain College of Engineering, Belgavi. This is the fifth video of this is the sixth video of module 4, and we'll be looking into the power electronics 7th semester. So in module 4 we are basically dealing with DC to DC chopper, and we are referring to the textbook of Mohammad Rashid, Power Electronic Circuit Devices and Applications. So coming to the content, we have been looking into the step up chopper, the step down chopper with R and RL load. We have also seen certain examples with respect to the chopper, example problems and performance parameters we have seen. And now let us move on to the converter classification. So basically classification of choppers can be made as follows. That is, we will have the class A chopper, which is basically the first quadrant chopper. We have got four quadrants with respect to the load current and load voltage. So in the first quadrant, both the voltage and current will be positive. Then we have the class B chopper, which is the second quadrant chopper, in which case you will have the voltage, the second quadrant in the four quadrant operation. Class C chopper is first and second quadrant chopper. Class D is first and fourth quadrant. So likewise, class E will be all the four quadrants. So coming to the class A, this is your class A chopper, and we can see that in the circuit diagram, the chopper is connected in series with the input voltage. We have the freewheeling diode, so it's very similar to the step down chopper. And in this case, when the chopper is on, the input supply will be connected to the load with plus minus. So I will get positive voltage at the output. And when the chopper is off, the load, it's like an RL load, so it will freewheel the current through the freewheeling diode. So again the current flows in this direction only. So the current is always positive and the voltage is always also positive. So when the chopper is on, the supply voltage V is connected to the load. This is again explanation. And when the chopper is off, V naught is considered as 0 because ideally we are considering the diode drop will be 0 because it is conducting. And the load current continues to flow in the same direction through the freewheeling diode. The average value of the output voltage and current are always positive. So the class A chopper is the first quadrant chopper. So in class A chopper, it's basically, as I told you, it's nothing but the step down chopper in which power always flows from the source to the load. And it is used basically to control the speed of the DC motor. And the output current equations obtained in step down chopper with RL load can be used to study the performance of class A chopper. So if you look at this diagram, this is the gate current that is being given to the chopper. So whenever the gate current comes, because input is DC, the chopper is going to be forward biased all the time, but it will conduct only when the gate pulse arrives. So when the gate pulses are given in this fashion, so in this case we have the gate pulse here and the chopper is going to conduct, and as the chopper conducts, the current flows to the load and it is of the increasing fashion. When the chopper turns off, the freewheeling diode will conduct, and it is this time during which the load will discharge through the freewheeling diode to itself. Okay, but the current in both the cases are always positive. And the phenomenon repeats further on. So the T on is nothing but the on period of the chopper, and this considering T off, this becomes T, which is T on plus T off, and that is the chopping frequency. Now coming to the class B chopper, this is the second quadrant. In this we are seeing that the voltage is positive but current is negative. So if you look at this particular circuit diagram, it reminds you of the step up chopper. So what you find is basically when the chopper is on, the current is going to flow from the load and freewheel through kind of this. So the voltage will be zero across, but the current will be negative. And when the chopper is off, the load voltage will feed the supply voltage, okay, through the diode D, which turns on when the chopper is off. So in both the cases, the current is in the direction opposite to what has been shown here, and hence we say it is the negative voltage. Okay, so the voltage in both the cases, when this conducts, it is going to be zero, and when this conducts, the supply voltage will be connected in this fashion, and voltage is always going to be positive. Okay. When the chopper is on, E drives a current through L and R in a direction opposite to that shown in the figure. During the on period of the chopper, the inductance L stores the energy. Okay, and when the chopper becomes off, the diode D conducts this stored energy, and part of this energy stored in the inductor, it will return it to the supply. So the average output voltage is always positive. Average output current is negative. Therefore, class B chopper operates in the second quadrant. In this chopper, power flows from the load to the source. Kindly note this. And class B chopper is used for regenerative braking of DC motor. So class A is basically used to control the speed of the motor to make on and off. Okay, and whereas this is basically used for regenerative of the motor. So if you look at the waveform here, the chopper is turned on here whenever it gets the gate pulses, and when it is not conducting, when the chopper is off, the diode D will conduct. Okay, so when the diode D conducts, it is connected to the supply, in which case we can say the E value, and along with L, it is supplying to V, and the current is going to increase from I minimum to I max. When the chopper conducts, it is sort of discharging, as I said, right? So the current will be of decreasing fashion. Okay, and the output voltage is always positive when the diode conducts. V is connected to the load, and when chopper is conducting, the output voltage is zero. So this is the waveform for class B operation. Now coming to the expression of the output current. So during the interval diode D conducts, voltage equation is given by C. When the diode conducts, this is off. So according to the voltage equation, we have this path. So V is equal to L into di by dt plus R into I naught plus E. Okay, and for the initial condition, we have seen this waveform. When the diode is on, here reconducts, the initial value at t equal to 0 is I minimum. So if I substitute I naught of t equal to I minimum, the solution, we have done this solution for basically the step down chopper with RL load in our earlier videos. Please kindly look at it. And I am going to get an expression as I naught of t equal to V minus E by R into 1 minus E to the power of R by L into T plus I minimum E to the power of R by L into T. This is the expression when diode conducts, that is from T is equal to 0 to this particular period when off period starts. Now at t equal to t off, at this point, you can say that I naught of t has reached the I max. So substituting t is equal to t off in the above equation and I naught of t equal to I max, I get I max is equal to V minus E by R, 1 minus E to the power of R by L into, substitute for t as t off, plus I minimum E to the power of R by L into t off. So this is the expression that you will be getting during the T conduction, that is when chopper is off and D is on. Now during the chopper on stage, that is the next stage, during this period, okay, so the voltage at the load will be 0 and the equation will be 0 equal to L into di by dt plus Ri naught plus E. And in this case, if you see, the current is going to go at initial value of I max to minimum value out at the end of the period of T off. So redefining the time origin, let's take t equal to 0 at that time. So I naught of t is going to be the maximum. Initial value will be maximum. And the solution for this stated initial condition, again we have to do that derivation as we did in earlier video, where I will get I naught of t, this is the solution, equal to I max e to the power of r by L into t minus e by r into 1 minus e to the power of r by L into t. And this is the time when chopper is on between 0 to t on. Now at t on, at the end of the off period, that is at in the beginning of t on, we know I naught of t is going to be I minimum. So in this above expression, let me substitute I naught minimum t is I minimum when t is equal to t on. So substitute wherever there is t as t on, okay, and you get this expression for I minimum which has I max here. So we got two expressions for I minimum and for I maximum. So those can be solved and you can find the values of I minimum and I minimum using these two equations. Next, coming to the class C chopper. The class C chopper is connected in this fashion. You can see there are two choppers, chopper 1, chopper 2 connected in this fashion and D1 and D2 connected in this fashion. Okay, and we have got the load connected between chopper 2 and D2. Now chopper C basically is a combination of chopper A and chopper B. So both the chopper A is here and chopper B is here. So let us look at this diagram. When does it behave as a chopper A? So the class C chopper is a combination of class A and class B. For the first quadrant, what is going to operate? If you remember the class A operation, you have got a series chopper connected to the load, right? And we have got D2 which is acting like a freewheeling diode. So for the first operation, CH1 is on and D2 conducts, right? Either on or D2 will conduct, any one will conduct, either chopper 1 or chopper 2. So for the second operation, we can have this chopper 2 which is coming in parallel with this, and we have this diode which is connected in series with B. So these are basically your class A and class B choppers. So when chopper 1 conducts, the load voltage is going to be, load current is going to be positive going from top to bottom of the load. The output voltage is equal to the supply voltage gets connected. You can see here. So the output voltage is going to be positive and the current is also positive, and hence it is first quadrant operation. When the chopper turns off, the diode takes over and the current continues to flow from top to bottom. Hence current is positive and voltage is going to be 0. So it is basically operating in the first quadrant. So I have re-explained it in this fashion. This was the class A chopper where we had a series chopper like this and we had this freewheeling diode connected to the load. So that was your class A chopper. And in class B chopper, we had this chopper in parallel with the load, right? And we had this diode which is connected to the load. So in class B also you can see how when the diode connects, the voltage will be connected to the input, hence it is positive, but the current direction is from down to top, hence it is going to be negative for the class B chopper. The same thing is observed. So two circuits are clubbed and put it into one. So when the current continues to flow in the positive direction, okay, when chopper 2 is triggered, now this is class B. When this is triggered, the voltage E is forces current to flow in the opposite direction, in this direction, okay, through the L and chopper 2. The output voltage, obviously, because chopper is connected in parallel with this is 0. So output voltage will be 0. On turning off this particular chopper, the energy that is stored in the inductance drives the current through the load D1 and the supply. So supply gets connected when D1 is on. So the output voltage obvious will be V, that is plus minus, right? Because plus gets connected through the diode. So output voltage is V, but the input current, if you see, because the input current is discharging like this to the source. So in class B, the current flows from the load to the source. And hence it is opposite, and that falls in the quadrant 2. If you look at the average output voltage, it is positive. The average output current can take both positive and negative values depending upon which choppers are conducting. So chopper C1 and CH2, they should not be turned on simultaneously. You'll note that they are in series and connected across the supply. So if both of them are on, then the supply gets short circuited. Class C chopper can be used. Where do we use it? As I said, Class A was used to control the speed of the motor, that is accelerate and reduce the speed of the motor. Class B is basically used when you are applying the brake, that is for regenerative feedback. And hence Class C can be used for both the control of DC motor as well as the regenerative braking of DC motor. The Class C chopper can be used also as a step up or step down chopper, as we have seen. So this is the waveform that we are getting, and this is your Ig2 and Ig1. Ig1 is for CH1, Ig2 is for CH2. Gate pulses are here. So when chopper 1 is conducting, it is between this point. See, chopper 1 and D2, they have to carry the positive current. Hence you will get the current, rising current when chopper 1 is on, and the discharging current when D2 is on, but they are always positive, that is above the T line. And when chopper CH2 conducts and D1 conducts, their current has to be negative, right? So when CH2 is conducting, right, the current will flow in this direction, right? So it is going from here and reaches the maximum. And when D takes over, it is going to discharge to the source. So when CH2 and D1 conducts, it has to be negative. Remember this. And when CH1 and D2 conducts, it has to be positive, that is above the T load, T line. And when does output become positive? Whenever either CH1 or D1 conducts, because they are the one which are connecting to the supply voltage. So when D1 and or CH1 conducts, that is during these two period, output will always be positive. And when D2 and CH2 conducts, output has to be 0. So I plot a 0 during D2 and CH2 when they are on. Okay, so this is the waveform for your class C operation. Next, coming to class D operation. Now, if you look at this connection, you can see there are two CH1 and CH2 connected in opposite branches of the load, and D1 and D2 are connected on the other two branches of the bridge. You can call this as a bridge, and the load is connected between this. And this class D basically is also a two quadrant operation, and it operates between the first quadrant and the third quadrant. Okay. So what you will see here is chopper 1, when does the supply connect? So the output voltage, okay, what does we understand from this? That the voltage can be positive or negative, but the current is always going to be positive. So when you say positive current, it is flowing from this direction to this direction. So when this chopper CH1 and CH2 is conducting, the supply voltage gets connected to the load and the output voltage is positive and the current is also positive, and we can say that the chopper is working in quadrant 1. When they are off, Then D1 and D2, they come into picture and they carry the current or discharge or connect the supply voltage again to the load, but the positive gets connected here, right? And the negative gets connected here. So the voltage polarity will reverse, but the current direction is of the discharging of L in the same as previous direction. So current through the load will be positive, but the voltage across the load will be negative. So this is your class D chopper. So class D is a two-quadrant chopper. When both CH1 and CH2 are triggered simultaneously, the output V naught is equal to 0 and output current flows through the load. When CH1 and CH2 are turned off, the load continues to flow in the same direction through the load D1 and D2 due to the energy that is stored in L. Again, output is equal to minus V. So here, sorry, I said 0. V naught is equal to V, as I explained earlier, when CH1 and CH2 conducts, and when D1 and D2 conducts, output is equal to minus V. Okay, and the current will direction will change. When these two are conducting, current will be in this fashion. When these two are conducting, current will remain in the same direction. Okay, so only the voltage will be changing. The average load voltage is positive if chopper is on time is more than the off time. So if how do I make positive current? We have to look at the average value. So average value means T on. Chopper is going to be on for some time and then diode will be on. So if chopper is going to be on, so for more time, so output of the load will be positive for more time. So the average value will be positive. Average means combining on and off time. And hence average output voltage will become negative if T on is less than T off. That is, if diodes are conducting for more time, then negative voltage across the load will come for a larger amount of time and positive voltage will come for smaller amount of time. And hence the average is going to be negative. Hence the direction of the load current is always positive, but load voltage can be positive or negative. Let's see how that happens. Now in this is the same circuit, okay, class D, and you can observe here these are the gate pulses given to chopper 1 and chopper 2. Since both have to operate simultaneously, the gate pulses come at the same time. And when these two choppers conduct, we know that output voltage is going to be positive, right? And equal to the input supply. And the current is going to be of the rising type. So we are going to have current here when chopper CH1, CH2 is on. And when they are on, I'm going to connect our output load will be connected to the input supply and hence it will be positive. Note that the on time is larger than the off time. And what happens during the off time? D1 and D2 are going to be off. And because of that, the positive voltage will be connected to this terminal. Negative voltage will be connected to this terminal of the load. Hence, this becomes positive, this is negative. Hence, I am going to get negative voltage at the load. And the duration of this negative voltage is much so small. So if I take the average of these two, obviously the average will be always positive. Hence, if you look at the chopper, it is giving you an average output voltage of positive. So by controlling this on and off time, average value can be controlled in the positive direction provided T on is always greater than T off. Then how do I get the negative? So what I do is the chopper CH1, CH2 which are turned on simultaneously will have an on time which is lesser than the off time. So when it is on these two choppers, the current is going to increase like this. When it is off, keep the off time long. So when chopper is on, we know output is going to be positive, and when the diodes are on, we know output is going to be negative. So if you see, the negative is more than the positive in one any given cycle. So the average value is going to be negative. So in this case, I am going to get average value as negative, but the current, if you see, are all above T, whether chopper conducts or diode conducts. So this is your chopper D. Now coming to chopper E. Okay. Now this is basically all the four quadrant chopper, and it is a combination of all the circuit diagrams that we have done for A, B, C and D. Okay, so for that sake, you will have to remember these currents, the circuit diagram. So we'll have CH1, CH2, CH3, CH4, and D1, D2, they are all in the opposite direction to these, and D3 and D4. So to remember the circuit diagram, it's simple. And remember to connect the voltage in this fashion, right? And the load will be here, all connected here. Okay, so the load is between this. Now who conducts, what conducts in this way? This is how the control of motor and braking of motor in the positive direction as well as in the negative direction is observed. So if you see four quadrant operation, class E, we call it as a four quadrant chopper operation with CH1 and CH4, right? These two are triggered, output current are going to flow in the positive direction. So always these two will carry the current in the positive direction through CH1 and CH4, and output voltage is going to be connected to voltage, right? That is V. So it is output voltage is positive. This is going to give me the first quadrant operation. Okay, because both voltage and current are across through the load are positive. When both CH1 and CH4 are off, the energy that is stored in the inductor L drives this current through D2. Okay, this D2 and D3. Where is D3? Here, like this. So the current will remain positive only, and voltage across the load will be negative. So you can see if this is D3 connected, D3 gets connected here. So positive gets connected this side, negative gets connected this side, right? And output is now going to be negative. So this is how we control the output voltage to be positive, okay, as well as negative, but the current is always going to be positive. Therefore, the chopper cooperates in the fourth quadrant operation. Hmm? When chopper CH2 and CH3 are triggered, when these two choppers are triggered, the load current is going to flow, right? The load current will always flow in the opposite direction, and output voltage V naught connected would be again negative, because this will connect the input supply to this point. This chopper will connect the negative voltage to this point of the, so the load will have a negative voltage. Since both I naught and V naught, and how is the current going to flow? Because you just see the direction, the current will always flow opposite to what we did previously. So the voltage is negative, the current is also negative, right? The chopper is said to be in which quadrant? Both are negative, third quadrant operation. Okay. When both CH2 and CH3 are off, when they are off, the load current continues to flow in the same direction in D1 and D4. So D1 and D4, they will take over when these two choppers are turned off, that is CH2 and CH4. So the current was being flowing through like this, and when they turn off, these two take over, so the current will flow through the load in this direction. So the current is going to be in the operates in the second quadrant because now the voltage will be connected this positive and this as negative. So you will get voltage, output voltage as current is going to be negative but voltage will be positive. Hence, which quadrant this operation is? This operation would be operates in the second quadrant as V naught is positive but I naught is negative. Effect of source and load inductance. So these are the four we have seen classes of operation in with respect to the quadrantal operation of the chopper. And here we can see how it is easy or it is possible to control the speed of the motor, decrease the speed of the motor in the clockwise direction, as well as increase the speed and decrease the speed of the motor in the negative direction, that is reverse anti-clockwise direction. So both the forward control of the motor as well as the reverse control of the motor is possible in class E operation or four quadrantal operation of the chopper. Now let us look at the effect of source and load inductance. The source inductance should be as small as possible to limit the transient voltages. See, because we are doing continuously on off, one is on, the other is off, right? And then that becomes off, and then this the which was off earlier that becomes on. Switching actions are a lot in this kind of chopper devices. So if the load source inductance gets affected. So if the inductance is into picture, it is going to affect the chopper operation to a considerable level. So we should keep the source inductance as small as possible. Also, source inductance may cause commutation problem of the chopper, as I told you, because of the switching action. When it has to turn on, it may not be possible to exactly turn on. And since we have to have proper understanding when we have to turn on two devices on simultaneously. If they don't turn on, then the on time period could be different or shorting could happen. So these issues are there in chopper. Usually an input filter is used to overcome the problem of source inductance. The load ripple current is inversely proportional to the load inductance. So if the ripple value of the current depends on the load inductance and also the chopping frequency. Next, the peak load current depends on the load inductance. If the load inductance is more, it can store more energy, right? And hence the peak current value will also change. To limit the load ripple current, a smooth inductor is connected in series with the load. So we know that when I add an inductor, it acts in series with the load. It acts like a reducing the like a filter. So definitely reducing the ripple in the current. So in this video, basically, we have been looking into the classification of chopper with respect to the quadrantal operation of the chopper. So we have done class A, class B, class C, class D and class E with respect to the circuit diagram, with respect to the quadrantal operation, and we have tried to understand how a motor can be controlled both in the clockwise as well as the reverse anti-clockwise, and also braking, okay, regenerative braking effect also we have seen in this particular video. In the forthcoming video we will be looking into other type of converter classifications such as switch mode regulator, buck regulator, boost regulator, buck boost regulator, and we'll also look into the chopper circuit design. So I thank you, dear students, for this patient listening. And if you have any doubts, do get back to me. Thank you so much.